Hello, everyone. Thank you so much for being here tonight. I'm Liz Bridgewater, the Director of Outreach at Climate Action Now, and one of many people who work to bring this action party to you tonight. It will be just a few moments while people continue to gather. While we're waiting for more folks to join, I invite you to answer the icebreaker trivia quiz that you'll see pop up in just a moment. All right, you should be seeing that poll now. We've got a few questions for you this evening. The first question is, where is the majority of the world's ice mass? Secondly, when sunlight reflects off of fresh snow, how much of that sunlight is reflected back into space? And finally, what's the scientific term for ice you didn't expect on your windshield at 7 a.m.? While you're trying your hand at this trivia quiz, if you're feeling up for it, please also share your video so we can all see each other tonight. We will be recording this action party and it will be available publicly online. If you do not wish to appear in any shared content, please keep your camera off. We'll send out a recording tomorrow. If this is your first ever action party, let me give you a quick overview. An action party like this is an opportunity to learn about important environmental issues from people who are experts in their fields. In the course of the same hour, we're going to use the Climate Action Now app to take action together. The Climate Action Now app makes it easy to send well-researched, personalized messages to political decision makers and to business leaders. To show you why it's so easy to take action with the Climate Action Now app, I will share my screen for just a moment. Alrighty, so this is an example action like the one that you'll have access to tonight. It only takes 3 touches to take an action. First, you touch Do It Now. Then you can choose how you want to contact the decision maker that you're reaching out to. Because the app has your address, it will automatically know who your federal, state, and even sometimes your local officials are. Then you just have to hit send, and you've taken an action. As you take actions, you're going to earn points. When you earn enough points, Climate Action Now will plant a real tree on your behalf. So far, Climate Action Now has planted over 398,000 trees together. Let's share the results of our icebreaker poll now. Kaylee, would you share those results?
Of course. Hello, everyone. I am Kaylee Beam, Climate Action Now's Director of Content, and we're just going to see how you all did on tonight's quiz. I did want to say sorry. I think it got ended a little early, so apologies if you couldn't participate, but doesn't matter. We're going through the results all together. So you should be seeing the results on your screen. The answer for our first question is Antarctica. Looks like most of you got that one right. So almost 90% of Earth's ice mass is in Antarctica, though the Greenland ice cap contains another major portion of total global ice mass. On to our second question, which is, when sunlight reflects off of fresh snow, how much is reflected back to space? The answer is actually a whopping 90%. So as you may know, the fraction of sunlight reflected by a surface is known as its albedo. Surfaces like snow and ice have incredibly high albedo, so when they melt, darker surfaces with lower albedo are exposed. When this happens, less solar energy is sent back to space, driving more planetary warming. That's why doing what we can to mitigate climate change and prevent further ice melt is so important. And on to our last question. What is the scientific term for ice you didn't expect on your windshield at 7 a.m.? So I'm sure this one had everyone racking their brains, but it is in fact a trick question. Sorry we pulled a fast one on you, but we just couldn't resist. And while there may not be a correct answer, looks like the top answer is cryoadhesive surprise effect. I do like that one. It is a pretty good acronym. I think my personal favorite, just because of the alliteration's got to be passive aggressive precipitation. So thank you for humoring us with our little trivia quiz. And more importantly, thanks for being here tonight to learn about the importance of our icy landscapes and why protecting them matters. So before we get to our panel discussion, I'm going to quickly get us all ready to take some action tonight. All right, so let me just share my screen. You should be seeing it shortly. All right, there we go. So if you're an Action Party regular, you already know what to do, and you really don't need me to walk you through it. but if this is your first time attending, this is our goal tracker. So on the left side, we have this globe that will iterate and fill in as we take action here tonight. And on the right side is a QR code, which is what you're going to scan to get into the app. So go ahead and take out your phones or tablets, open up your camera app, and point it right at the QR code box on the right side of the screen, under where it says Current Action. As you're pointing your camera at the QR code, a little yellow bubble that says Climate Action Now should appear, and once it does, just tap on it. If you don't have the Climate Action Now app already, tapping that bubble will take you to the App Store, where you can download it for free. Once you have the app, all you need to do is follow the prompts to sign up, and it will take you right to tonight's campaign, which is titled Save the Ice. So I'll give everyone a moment to get in there. If it's not working for you, don't worry. You can also go to your phone browser and type in the link that's directly under the QR code right here where it says CanApp link/save the ice. And I can drop that in the chat if need be. Just like the QR code, that link will take you to the campaign if you have the app or to the App Store to download. And if you're still having trouble, seriously, don't sweat it. The campaign will still be open long after today, and we'll share detailed instructions in our event follow-up email along with the recording. So once you're in, feel free to take action all event long. I've set our starting goal at 400 actions. I definitely think we can blow right past that, but let's do our best to get there. So that's all for me. Back to you, Liz.
Thanks so much, Kaylee. Next, I'd like to share that unfortunately our original moderator, Robert Hubble, is unfortunately able to join us due to an unexpected conflict. Instead, we will be joined by Brett Walter, the founder and CEO of Climate Action Now, as he moderates our panel discussion tonight. With no further ado, we're going to transition into our panel discussion now, moderated by Brett. As you hear from our panelists, please share any questions you have into the chat. Over to you, Brett.
Well, thank you, Liz, and thank you everybody for joining us. And we're already at 66 actions. You guys are incredible. I can tell from that we have some pretty hardcore can-doers, as we call you, people who use the Climate Action Now Can app. Thank you guys so much. I think this is going to be an insanely interesting hour for you. We have an incredible panel, some of whose names you know and some you don't and should know. So let me kind of introduce our panel here right at the top of the hour. Kim Stanley Robinson, I know is known to many of you, goes by Stan, by the way. I get to call him Stan, so that's kind of cool. He's a celebrated science fiction author, including Ministry for the Future, a novel that explores climate solutions. And if you just bear with me for a second. Liz, can you shoot me that thing again? I'm sloppy little fingers on my keyboard and I killed my notes.
Yes, definitely.
Oh, wait a minute. You don't need to resend it. I've got it. Sorry about that, everybody. Yes, in his Ministry for the Future, he explores climate solutions through science-driven storytelling. Stan's writing also often blends ecological, political, and scientific themes and has earned honors like the Hugo and Nebula Awards. Stan's a supporter of the Ice Preservation Institute, which explores ways to slow sea level rise. Durwood Zaelke is the founder and president of the Institute for Governance and Sustainable Development, which promotes fast climate mitigation to slow near-term warming and self-propagating climate feedbacks. Durwood is an expert in international environmental law, has taught at many of the world's top law programs, and was named one of Washington, D.C.'s most influential environmental leaders by Washingtonian Magazine in 2022. And Dr. Leslie Field is a personal friend of mine. She's also an engineer, an inventor, and founder of Bright Ice Initiative, which works on technologies to slow ice melt by enhancing ice reflectivity. Leslie holds engineering degrees from MIT and UC Berkeley and has taught for over a decade at Stanford. Her climate-focused innovations have been shared at the United Nations, the World Economic Forum, and the Arctic Circle Assembly. That is our team. What a crew. This is going to be great. Okay, so let's get into it. The format today is Q&A, and we're up to 143 people. Woohoo! Oh, and panel, I forgot to warn you, when we hit our goal, somebody on the CAN team is going to rudely interrupt you to call attention to the fact that we've hit our goal, and then we will set a stretch goal for people who are attending today. So let's get started and start by talking about the problem, and then we can move on to solutions. So the Intergovernmental Panel on Climate Change, the IPCC, which many of you know is sort of the gold standard scientific body on climate change, they forecast that global sea levels will rise 1 to 3 feet by the end of the century, depending on emissions. So to many people, that may not seem like too much over such a long period of time. So I want to ask everybody on the panel, we'll just go around the table. What do you think about that? Why does melting ice matter, and why should we be talking about it right now? In other words, what's at stake?
Who do you want to start with?
Leslie, you want to go for it? Oh, wait a minute. I'm sorry. I have actually a special question. So for you, Durwood, what are your thoughts on that?
I think it's going to be a disaster, and I think the IPCC is underestimating the risk and the impacts we're going to suffer from the loss of the different ice sheets and the sea level rise that we're going to face. Some of this is a relatively slower moving problem, but we're probably already locking in the disintegration of the Greenland ice sheet. What's that? That's 7 meters of sea level rise. Might take a little while, but on the other hand, as the surface melts and the water percolates down through the moulins to the bedrock, it lubricates the ice, and it can disintegrate and be pulled into the ocean by gravity. And as you lower the surface, you get more algae that's darker, reduces albedo, starts melting faster. The lower the cap is, the warmer it is. So there are feedbacks built into the system. I think it's going to be a lot worse than the IPCC says. They're very conservative. Many people do think they're the gold standard, but they're kind of the slow gold standard that rarely is at the cutting edge of where the science is.
Okay, great. Leslie, what's your reaction?
Yeah, great. I'd love to add to that. So we've had John Englander inform us at times about what sea level rise looks like for agriculture. And it's that it isn't just the level that you're 2 or 3 feet or whatever's going to happen, but it also propagates inland farther, ruining your ability to have crops, if it's salty water coming over what was to be your farmland. So that's just another ugly facet of that it tends not to be appreciated. And then you're so right, Durwood, about the IPCC seems to be constantly behind the curve. And what I've heard that being explained by is that people don't tend to think exponentially, but that's of course what's happening with the positive feedback loops. Things just, happen faster and faster if you've got that kind of effects, and all of what you described, Durwood, is a positive feedback loops, right? So it's
okay. Thank you, Leslie, and Stan. I know you've expressed concern in your interview with Sam, our Climate Action Now's editor-in-chief, about tipping points. What are your thoughts about the situation here?
Well, I would just reiterate what Durwood and Leslie have said. The IPCC has to make statements that they can back up, and they want them to be solid and uncontroversial. So these are very conservative statements indeed. And they also are not, no one is very good at taking in non-linear breaks, such that if something like the West Antarctic ice sheet were to begin to disintegrate, that could happen much faster than an ordinary linear progression would indicate. The thermal expansion of the ocean itself, just by warming up, that's already a kind of a meter rise of sea level everywhere. And what I'd say we'd lose there is the beaches of the world. And since I grew up on beaches and I love them, and beach culture is a major part of world culture. The loss of those, which is already, as Durwood put it, kind of baked in this case, literally baked in, is a sad thought. But the problem is that as it gets more than that, it gets much more dangerous to coastal civilization. And something like 25% of the world's population lives within 50 kilometers of the coast, and the wreckage of the coasts of the world is going to be a severe blow to civilization.
You know,
Okay.
let me jump in too, because I grew up in Southern California as a surfer, Stan. And it is extremely sad to think that we will have not a single sandy beach left in the world. It'll be mud and rock. I mean, that's an incredible loss. I know there are worse things that are going to happen because of sea level rise, but that alone breaks my heart.
Yeah, that's an interesting image. No one's ever said it that way to me before, Durwood. That is brilliant. Thank you. I want to drill in. We've been talking about sea level rise as sort of the obvious consequence of rising temperatures, but sea ice isn't the only kind of ice, right? We have glaciers, land ice sheets like the ones on Greenland. So let's talk about different kinds of ice. Or is that a meaningful metric for us to take a look at? Do you think differently about the problems when you think about different kinds of ice? Leslie, over to you.
Yeah, I'd love to talk about that one. So I started out focusing on sea ice, but it's difficult to get permissions to actually do experiments on sea ice, interconnected oceans, and so if we don't get permissions, we don't do it. So we got invited some years later to work on glaciers, and glaciers it's really important because when you've got sea ice melting, it's already on the ocean. It doesn't raise sea level nearly as much as when you've got glaciers melting and dropping ice that wasn't connected with the ocean before into the sea. You've got far higher sea level rise. So that's one problem. And then the other problems, of course, are the vast flooding that you get from sudden melts, the glacial lake outburst flooding, the ruining your hydropower, and you're ruining your agriculture, either from too little water or too much. So those are things that I think add to everything else that's been said so far, which really, in my mind, is like, oh my God, endless war over vital resources. When there's not enough food or water or safety, good Lord, that's not where you want your kids growing up, right?
Right. And Durwood, what are your thoughts about glaciers, for example?
Well, the distinction that Leslie made is very important. So, for the Arctic sea ice, which is floating on the water already, we're not so worried about sea level rise from the loss of that, but we are worried about the loss of its great white reflective shield.
Yeah.
So it sends most of the incoming solar radiation safely back to space. When we lose it, because it's too warm, and the Atlantification, the warm water, and the fact that the Arctic is warming at 4 times the global average, that means that it's replaced with darker ocean water that absorbs much more of the warming, sets off a feedback loop that then starts accelerating the thawing of permafrost, what we used to think was permanent frost. That releases more climate pollution in the form of CO2, N2O, and methane, one of the super pollutants. So, that and then you've got, as I'm often reminded, you've got the snow and ice on land in the Arctic, which one of our friends, Leslie, always tells us is an equal problem. When you lose the summer sea ice, you're adding the equivalent of 25 years worth of current warming. And so if that happens, and you get the same from the land-based snow and ice, you set off a wicked cascade that thaws the permafrost and sets off other feedbacks and tipping points. So it's right out of one of Stan's books.
Right. And
I'm
Stan, how
sorry
about
to
you guys?
interrupt the discussion, but I did just want to say that we reached our action taking goal already. Good work, everyone. Enjoy those fireworks because I'm about to update the goal to 650. So keep up the good work, and I think we can get there. Appreciate all you do. Back to you, Brett.
Yeah, well, if you know how to shoot off rockets like that, please feel free. So great. And Stan, how about you? Any thoughts on different kinds of ice and impacts and so on?
Well, yeah, I would just want to follow up on what Durwood said. It's really actually quite worse than anything I've ever written in any of my novels. Although in New York 2140, maybe I approached it kind of sideways or after the fact in having a sea level rise of about 50 feet. But that was a thought experiment that focused in on the New York City area exclusively and uh, might have been unrealistic as to um, how bad it would be for civilization. In other words, I might have portrayed a still functioning human civilization that wouldn't really be capable of doing so if all these things happen. Just to reiterate, the mountain glaciers, that's water for the countries around the Himalayas, so about 2 billion people. And then the ice sheets, they contain enough water to raise sea level by many meters if they were all to melt. And Greenland and the Western Arctic ice sheet are susceptible to more rapid melting than Eastern Antarctica, which admittedly is a nice, big, and stable bulk of ice. And then it's good that you mentioned permafrost. That's a mass of ice. It's hidden because it's mixed with soil and under the soil, and it will melt from the top down. But as it melts, as Durwood pointed out, it will release all of these gases that are trapped in it into the atmosphere and redouble the warming. And it's just very well put, a wicked cascade, a positive feedback loop in a negative direction to where we could slide down the slippery slope into what's called a runaway greenhouse effect. And at that point, it has to be said, and at some point, we're going to have to try some hooks to hope in this discussion. But if we initiate a runaway greenhouse effect, then say at that point, the entirety of human civilization agrees we have to devote the entirety of human civilization's efforts to stopping that runaway greenhouse effect. We would not be able to do it anyway. We don't have the physical power. We don't have the means to stop a runaway greenhouse effect once it gets going. That simply doesn't exist as a human capability. So we want to stay away from that, and we don't know how close we are to it, but we're getting closer fast, and so it becomes a kind of an emergency situation.
Right. Okay. Thank you. Okay, so I'm going to mix it up a bit and take sort of a devil's advocate thing. I notice I read a lot of the press. It seems like a lot of people, and especially in the current administration, seem to view melting ice as an opportunity, opening up new sea lanes, in the north and opening up vast tracts of sea and land for exploitation, hence President Trump's interest in Greenland. So the world is warming, ice is melting. This is a great economic opportunity. What are they getting right or wrong with this kind of thinking? Durwood, go ahead. You had.
I mean, they're getting everything wrong. We have enough hydrocarbons to cook the world over several times. We don't need more. We don't need to go into the pristine places like the Arctic. The Arctic sea ice actually is very important for national security reasons. So it is part of national security. And if you lose that, you're more vulnerable, and you open up the shipping lanes between two countries that the U.S. Has to manage relationships with carefully, Russia and China. And so seeing them become better partners and the U.S. losing its natural security defenses is really short-sighted, let alone catastrophic for climate change.
Right. Anyone else like to comment on this? Leslie,
I I just want to reiterate what Durwood said. It's really it's short-sighted, but also incredibly blindered. The negative effects outweigh any superficial and trivial positive effects by 10,000 to 1. So it's strange the stupidity and the destructiveness of these points of view. It results from some kind of a Gerda Damerung end of the world type stubbornness or a joy in the destruction of the hopes of other people, especially Democrats. It's just bizarre and can't be defended on any level. There is no strategic advantage to losing the ice on this planet because it'll blast us into a hothouse Earth and destroy human civilization.
And I've recovered enough now that I could actually answer this, Brett. We destroy, to follow on what Stan is saying, we destroy all the natural capital we have, all of the value of the food and the ecosystems, the species that are here, is just an absolutely short-sighted, tragic thing to do. And it's just unconscionable. We should do everything to not get there.
Okay, I'd like to transition from the problem, which we all know is pretty big, to solutions. And before I get in, I have a couple of questions of my own for the panel, but but for people who are participating, please type your questions into the chat. When I finish a couple more questions, Liz will start asking the panel some of the questions you all can get into the chat. So please take advantage of that. So moving into solutions, I'll state the obvious, which is we know the root cause of global warming is greenhouse gas emissions, which continue to rise. So as emissions are continuing to rise, so the problem's going to get worse. Is there a single action that any of you would prioritize that would make the most significant near-term positive impact? So let's go around the table again. Start with you, Durwood.
You have asked the right question. What should we do that is fast enough to slow down the self-amplifying feedbacks and avoid the non-linear catastrophic tipping points that are right around the corner. They're lurking right past 1.5 degrees Celsius where we are today. So one of the strategies that I think we have to put in this solution basket is the non-CO2 short-lived super climate pollutants. They have to be cut. So you have the HFC hydrofluorocarbon refrigerants, you have black carbon soot, you have tropospheric ozone, ground level ozone, and you have methane. And that's about half of warming when you look back historically. But when you look forward, which is the direction we really need to look, it is the solution set that can avoid 4 to 6 times more warming at 2050 than just decarbonizing the energy system, which we have to do at the same time. But the non-CO2 super climate pollutants, you can think of them as the sprint that we have to win in the very near term, the next 5 to 10 years, while we continue to run the marathon of decarbonizing the energy system. And let me just go on for one more minute, because the HFCs, or the refrigerants that I mentioned, they're under the control of the world's best environmental treaty, the Montreal Protocol. It's the best treaty because it's put the stratospheric ozone layer on the path to recovery by about 2060, and at the same time has done more for climate than any other agreement. It has avoided as much warming as CO2 is causing today. Think about that. It's avoided as much warming as CO2 is causing today. And it's on course to avoid 2.5 degrees Celsius of warming by the end of the century. So it's kept us from having the feedbacks push us past the tipping points. I mean, it's really saved the planet, and we need to study it. We need to understand it. And we need to replicate it for methane.
Right. So Stan, can you beat that? I mean, super pollutants, any other solutions that you would look for?
Can't beat that. That's really one of the crux things we need to do. So what else? Well, I've been saying that rapid reduction of fossil fuel emissions is the sine qua non. Without it, nothing. And so everything else that gets tacked onto that will not work unless we're doing that at full speed. But all of the other things that have been proposed that are sometimes loosely called geoengineering, these can be destranded from each other and discussed each method in turn. And all of them need to be investigated, and maybe all of them need to be deployed because we already have a carbon dioxide overshoot in the atmosphere, and we need to draw back down an immense amount of carbon. We may need to reflect a certain amount of sunlight. Different processes are being described under this same word, geoengineering, but all of them have this similar feature of an intervention that might help out. And in fact, Leslie's work in terms of trying to increase reflectivity is sometimes called geoengineering, and it resembles some of the other methods. And so maybe she should talk about that.
Oh, thank you.
You set it up perfectly, Stan. Go ahead, Leslie.
Yeah, I don't like being lumped under geoengineering because that typically is implying that we're doing something global all at once. I'm very proud that what we get to do is very low risk and acceptable to communities. So we're working with people who live there and know the area well as we do our experiments. And our experiments are deliberately small scale. That's what the ministries of environment and such and the experts, environmental impact assessment specialists tell us that is how we should be doing that. And so I'm very proud of all the frameworks that we've helped create from that sort of thing. But it does mean that you are going pretty small scale at first for your research, but you are being very effective. And we have done a implementation in the Himalayas just in 2024, just this last year, with some terrific glaciologist, EIA specialist, environmental impact assessment specialist, and terrific equipment so that we should be able to get some more good peer-reviewed information out there for the world to see once we've got our 3-year tests done. And the brightness that we got from shifting our material set a little bit has just been phenomenal. So it's a very hopeful thing. I will say that the people who worry about, well, how fast can you get this done? My answer, and I don't know if it sounds naive or not, but it seems realistic to me, is this is essentially like farming. We spread this stuff with seed spreaders by hand, and we're doing it in small areas so far. You can certainly imagine how to make that go faster and bigger if once you're convinced it's all safe. But it's and so far so good. The EIA specialist has dug in far enough. She's not seeing any bad things coming out of this at this point, and we didn't expect to either. So yeah, thank you for letting me chat about that a bit. It's and it also helps cure those soot problems. You're putting something bright on top of it, so you might have to replenish it, but okay.
Yeah, so I think maybe folks need a little bit more background information on what you do, Leslie. So you've been working on this, I think, for 20 years.
About right.
Yeah. Because I remember talking to you about it 20 years ago. And, oh my God, she's trying to do something amazing here, which is basically preserve the ice with an intervention, which involves, why don't you just finish the sentence for me? What, in a nutshell, what is your solution? How does it work?
Oh, we call it surface albedo modification. And that's trying to reduce any risks. So that means that we apply at this point, clay-based material, denser than we used to try on flat ponds, so it can stay in place on glaciers, and very bright and lightly engineered. And that's what we're doing. I mean, it's that simple. And I could show a couple pictures if you've got time for it, Brett.
Yeah, why don't we just take a look at that slide that showed where you divided that pond in half or whatever that was, so people can see the difference between
can get there. So yeah, here we are. Here's the slide deck. I'm not going to show you the whole deck. Oh, that's embarrassing, but okay. There's a lot of screenshots I take as notes sometimes. But let me get to this here, PowerPoint. Cooperate. That's the problem with not having it up from the beginning, I guess. Come on. Oh, shoot. Hey,
Okay.
Phil. Yeah, I'm sorry.
Maybe Phil can work on that in the background, but
Maybe.
basically.
Yeah, let me describe it to you at least. Yeah,
Right, go ahead.
that's too bad. I wonder why.
You can stop sharing now, Leslie.
Yeah, that is the cleanest way to get out of that, isn't it? Where'd my stop share go? It always goes up there. Apologies for that. Yeah, I had it queued up earlier. We've been working for years on a Minnesota homeowner pond, which had a pond liner on it and very isolated from everything else. And the picture that I would love you to see in your mind's eye here is that we had materials very much like what we're using now on glaciers, but on the flat pond that covered, we covered half of this pond and we didn't cover the other half. And even after snow has fallen and snow has melted, we've still got the big brightness that we had to start with in our implementation, looking a lot like snow. And the reason is that we chose something hydrophilic, and that makes it pretty darn safe as well. Yeah, thank you. Oh, Sam, yeah, this is the end of that season there. And then, and this is what it looked like, while it was getting snowed on and at first with snow on it and all. So that's the kind of testing that we do. We do A/B testing, right? And in the Himalayas, we found about double the brightness that we had from these materials on that homeowner pond, again, on small areas and distributing the materials by hand. I have a cute photo in the deck that you won't see, but of my son and I distributing, these things by hand with a seed spreader. And so you could think of this as something that people could do as a sort of proxy for agriculture and keeping their water where it should be, how it should be, so they can keep having their crops, which is really a nice thing.
That's really great. Sam, you can stop sharing. I wanted to stop you there because I'd like to give the audience an opportunity to ask questions. And I'm sure there's a lot there in the chat. Liz, have you been keeping an eye, maybe starting at the top? Do you have some interesting questions for the panel?
Yes, definitely. So maybe a good intro one for folks is a question from Kim. Can you please describe some nature-based solutions to save the ice?
I was looking at that, thinking about nature-based, and it might be a derivative effect because the nature-based solutions like for reforesting and afforesting, kelp beds, regenerative agriculture, and so on, that could be described as biological are reducing the carbon dioxide load in the air and then saving the ice as a derivative effect. The actual ice interventions, like Leslie's, what she just described, the ice preservation projects that are hoping to pump water out from underneath the big ice sheets in Western Antarctica in order to slow their movement into the sea by thumping them back down onto their rock beds and taking out the lubrication from beneath them. These are not exactly nature-based. These are engineering, human, technological interventions. And indeed, brightening or thickening the sea ice in the Arctic comes down to one proposal, 700 robotic vehicles, ships that are up there winter and summer pumping seawater up into the air where it freezes and comes down and is flocking, increases the brightness and increases the thickness and fills the lanes of water between the ice cakes that remain. Again, it's a technological solution. So I hope that answers the question that when it comes to saving the ice, you either cool the planet back down or you begin to try to manipulate the ice itself to hold on to it long enough to cool the planet down before it melts.
Okay. So what else do we have, Liz?
Definitely. Maybe a good question for Durwood. A question from Marianne. What specific strategies would you recommend to reduce methane, nitrous oxide, and other super pollutants?
Well, for nitrous oxides, they're also ozone depleters. They're chemicals that continue to deplete stratospheric ozone. So they could be put into the Montreal Protocol, and at least the part that comes from production of industrial acids. The agricultural part's a little trickier, but still could be fit within the Montreal Protocol. Methane is different. I mean, methane does not deplete stratospheric ozone, doesn't fit very well with that treaty. But the success of the Montreal Protocol should be the inspiration for a new sectoral agreement to address methane. Prime Minister Mia Amor Motley of Barbados, in fact, is calling for such a new agreement to get rid of methane, starting with the oil and gas sector, where we know that 70% of the leaks of methane, which is the same as natural gas, can be plugged at no net cost. So you could have an agreement that was an agreement to stop the waste of natural gas, right? How would that be? I mean, that could have a tremendous impact. You could avoid about 0.3 degrees Celsius of warming by the 2040s. So it's the single biggest and fastest strategy that we know that could work quickly.
Wonderful. Thanks for those great solutions.
Anyone else have it? Would anyone else on the panel like to respond to that question? Okay, what else we got, Liz? Oh, Leslie, you had something?
Yeah. One of the things that is really annoying to me is when people talk about natural gas as though this is the clean option. And of course it equals methane, which is what Durwood is talking about. And there's nothing benign about our excessive use of natural gas. I love that some climate people now are calling it unnatural gas, and that just seems putting into the conversation here.
Yeah, good.
Okay. Yeah, thank you.
And Leslie, what you just shared is making me think back to a comment that Felix has dropped into the chat talking about how the American Geophysical Union has rebranded the word geoengineering to climate intervention. So another example of how we've got really these narratives in the climate movement with how we refer to things can shape the way that people relate to them. And I know, Stan, in your interview with Sam, you had talked about potential alternatives to how we discuss geoengineering. Would you like to share a little bit about that with the group?
Oh, sure. I do think climate interventions is a really great way to describe this. And the fact that we work in a localized way with people who live there and have great expertise in what's needed and what's not needed is really the way to go. And I'm proud of having been part of an AGU panel, American Geophysical Union, where they were updating the framework for ethical and transparent and, inclusive ways to do the needed research that you need to do in order to figure out, well, is what we're proposing benign, beneficial, hazard? You really have to do that at a small scale with people participating with you, fully informed about what you're doing. And in our case, I'm really proud this Himalayas expedition had an EIA specialist who's indigenous to the Himalayas and who has directed and is going to be the arbiter of what the conclusions are about, are we harming anything about the water downstream, or so those kinds of things I think are rather distinct from what people generally, as far as I can tell, are thinking about when they're talking about geoengineering, which is do we have to test it? If nobody wants us to test it there, do we have to test it? Maybe we just do it when our backs are to the wall. And that I've been an engineer long enough, you can see all the gray hair, that I know there's always unintended consequences. So why not plan for them and figure out what they are and test that in advance before you commit the world to that. So, yeah,
Right.
yeah, that's
I
my
only
rant.
want to I only want to add to that geoengineering is a pejorative term now in popular culture, and it causes people to shudder. And so everybody who is proposing a climate intervention is trying to dodge that term and replace it with a more specific name that actually designates what they're proposing to do. And in my interview with Sam, which I very much enjoyed, I tried to do a quick taxonomy of various proposals that get bunched under the geoengineering name to show how different they are in what they're proposing to do, in what results they hope for, and what the dangers and costs might be for them. And until you get to that level of granularity, you've just got a vague world of incoherent fears and doubts that don't actually apply to our current dangerous situation. Because some of these interventions are going to be really necessary going forward, and they don't seem to have very many obviously dangerous side effects or unintended consequences. So it's time to blow up that term and move into the current situation that we're in and be more specific about everything that we're discussing.
Well,
You know,
I would just, I'm sorry, I would just add that geoengineering is what got us into this mess in the first place. I mean, that's basically what we've been doing while we've been burning fossil fuels. I'm sorry, Durwood, you wanted to say something?
That's right. But I was going to follow up with this is a risk analysis. We know we're in deep trouble on the climate side. And so we have to study the risk of the interventions. And I'm pretty sure we're going to find some that are worth the risk to tackle the climate emergency that we're in.
I could add this idea about geoengineering because someone said in the chat, what about population, a lessening of the human population? Well, yes, but how do we do that? Well, when women have their full legal rights on this planet to property, to education, then the birth rate falls. And this has been shown around the world as a demographic fact. And the more that happens, so therefore, women's rights is a geoengineering method, if you want to play that game of blowing up the concept. And indeed, we'll have less pressure on this biosphere when we have a lower human population, which will come naturally when we have justice and equality. So again, justice and equality become geoengineering methods. In other words, our relationship to this biosphere can always be called geoengineering, things that we plan to do, things that we do by accident. And so the term becomes useless, and you really do have to get particular about what you're wanting and what you're proposing to do.
Right. And by the way, we hit another goal. Way to go, everybody. What was it? 650, Kaylee?
Yep, we blew
Now
right past
786.
650.
Why don't we've got another 10 minutes, so maybe add another 100 or so actions for folks to take.
Okay.
Yeah, I'll take
And
it
by
to
the way,
750,
everybody,
so see if y'all can get there. We can do it.
we get there. Okay. Just want to point out for everybody, there are a lot of actions in the CAN app related to methane and other super pollutants. One of our volunteer action creators, Bill Murphy, has been just fantastic at staying up on things and creating literally hundreds of actions in the app. The campaign that you're taking right now, that will stay in the app for some time. If you were to come back and look at this goal tracker 2 days from now, we'd probably be up over 2,000 actions that are taken. So you guys kind of primed the pump. Congratulations. Just keep going while we have time. What else, Liz, have we got?
Yeah, while we're on the topic of methane, we've got another methane specific question for Durwood from Marianne. Marianne asks, do you have a perspective on livestock methane, which I believe is just about as large as energy methane?
Yeah, it may be the largest piece from agriculture. Politically tricky. Farmers have a tough time feeding the world, and that will get even tougher as the world continues to warm. So we have to find the right way, and we can start with diet. This is if we ate lower on the food chain and less meat, less dairy, we'd have a tremendous impact on methane because it does come from ruminants as well as manure pits and much else on the farm. So we have a lot of good research going on the feed additives. You know, that's sort of a compromise. Still have your beef and your mutton and so on, but at least make sure it doesn't emit methane in the process. And there's some genetic modification experiments that are going on as well with livestock. So, but that's a lot. That's one thing that people can do as an individual. You know, change the way you eat and encourage everyone else to have a healthier, less meat in your diet future.
And this is a great opportunity, Liz. You're probably thinking the same thing, to pitch our upcoming plant, what are we calling it? Plant revolution? Plant-based
Plant-based
revolution
revolution.
action party, where we will be mostly focused on alternatives to meat and dairy that are being developed. So that's going to be another really great opportunity for all of you to learn about how you can modify your diets without feeling like you're having to sacrifice, so much by doing so. How else? Anybody else like to talk about the livestock issue? Nope. Okay. Liz, what other questions do we have?
Yes, we've got a super ice specific question. I'd like to bring in a question from Donald. Donald says, my question is, how long do you think we have before the West Antarctic Waite's ice sheet collapses due to rising temperatures? Some call this the doomsday glacier that would cause up to 2 feet of sea level rise very quickly.
Well, I've been working with a group called Ice Preservation that studies this, and you can't put how soon a date on it because it is a non-linear process, and also we may manage to make human interventions in it to slow it back down, which is what they're working on. The thing about the West Antarctic ice sheet that maybe everybody knows already, but it has to be said, a lot of the land under the ice there is lower than sea level. So that, and also warmed by volcanic action. So that makes it particularly unstable. And the Thwaites Glacier is the one called the Doomsday Glacier. It's moving very rapidly into the sea, and it's quite big, about the size of Florida. So it and the Pine Island Glacier right next to it are perhaps a keystone in the arch, and when they disappear, the arch will fall. This could happen way faster than the IPCC has even looked at. And by that, I mean, I don't know, about 100 years out. But the problem is it may be unstoppable if it gets going within the next few decades. And then it will take some decades to unfold as a rising sea level process elsewhere. So that's the best I can do. And the people working on it urge me, do not focus on Thwaites. That might be already lost, and it might be a couple feet of sea level rise from Thwaites, but the rest of the West Antarctic ice sheet might be susceptible to being stabilized by human interventions, and this is what they're looking into.
Once again, folks, you did it. We hit our second stretch goal, and I think we'll just leave it at that, Kaylee. And if you all are inclined to just keep taking action, that'd be great. We've only got a few more minutes. So one or two more questions, Liz?
Yes, Brett, I think we've got a good wrap-up question that maybe everyone on the panel could speak to. So this question comes from Joyce. Joyce asks, besides doing can actions every day, I did it this morning, what are the top few things individuals can do to help?
Okay. Leslie, you want to start?
One of the things I've done over time that I'm quite proud of is teaching for the last 15 years or so. 30 students a year. Several of you, oh my gosh, 3 of you have been guest lecturers for me in my class at Stanford. And you've had a huge impact on the students. And of course, I then share, what I'm doing as well. And it really helps them go away from a mindset of just feeling terrified. You don't sign up for my class, Engineering, Entrepreneurship, and Climate Change, unless you're already worried. But they go from just that panicked feeling, you can see it, and I make them write essays every week. So so I get to see how they're evolving there. They finally start seeing they have some agency there. They can do something about it. And I think if we can, collectively help people understand they've got some agency here, they could help us survive rather than just say, oh, it's too much. We're all going to die anyway. Is a much better way to give ourselves a chance.
Yeah, the eminent climate scientist, Catherine Hayhoe, says the best thing you can do about climate change is to talk about it. And but not only to your friends and relatives, also talk to your legislators and business leaders and so on, which is why we created the CAN app. Durwood, what thoughts do you have on what individuals can do?
Educate yourself and vote. Vote, vote, vote. Okay. And the young people in particular, but all of us. I mean, we have 50% of the people in this country who don't vote. And if they were to come out and be educated about climate, we'd have a different government that would pay attention and accelerate the solutions that we know are available. Vote.
Right. Yes, absolutely. Political active. Well, just voting is political activism, right? Stan, do you have any thoughts for us on this?
Yeah, one of them is just to repeat what the others have said, eat less meat. That's something an individual can do that makes a big difference. And then burning less carbon in general, being mindful in carbon consumption, flying less, driving less. And this leads me to something that is maybe at first sounds strange, but I hope you'll see the point of it. Spend more time outdoors. Just go outdoors. Ordinary existence, if you calculate how much time you spend indoors every day, then try to increase the amount of time that you spend outdoors, even for your indoor activities, which I started doing about 20 years ago. You'll find you're burning less carbon and you also are living healthier and having a more intense awareness of the biosphere at large, the birds, etc. So it's simple, and it's usually advice I give to young audiences, but just go outdoors and see what the world hands you. And not only will you burn less carbon, but you'll experience more joy, which is important given how dangerous the situation is.
Great. Well, thank you. And so everybody look in the chat, lots of fantastic links. We've referenced before Sam's interview with Kim, which I thought was really fascinating. You'll see that in the chat. We have upcoming action parties on, so as we talked about, diet, which our panel is really zeroed in on, which is really great. We've been asked for those of you in the state of New York, we've been asked by climate groups in New York to help them get some key anti-plastic and other, legislation passed in the current New York legislative session. So if you're in New York or have friends in New York, be sure to join those action parties. We came this close last year to getting a major anti-plastic law passed. I think it even cleared one or both of the chambers in the New York. So sign up, use those links, sign up for all of these action parties, educate yourselves, talk about the problem, take action. Remember what we always say here at Climate Action Now, your opinion, public opinion, is the only effective counterweight to the immense power of the fossil fuel industry, which unfortunately right now basically owns the federal government. So your opinion, expressing your opinion is the most important thing that you can do, as well as modify your lifestyle. Leslie, did you want to get the last word in?
I do want to get a word in that I really should have mentioned before. I'm helping as a volunteer, someone who's trying to get balcony solar implemented in the San Francisco Bay Area. And I know about that because Sam wrote about that. And it's a lovely thing. And it's one way that you can certainly be talking about reducing the carbon intensity of what you're doing. So I figure the audience is going to be very excited.
And we even had an action party on this, Leslie and Liz. When you do the show notes in the email that goes out to everybody, would you include the link to the recording that we did with that group that is trying to bring balcony solar to the US? So much we can do, folks. It's never been more important that we do it than now. So I hope you've been inspired, to take action. And Thank you, panel. You guys were fantastic. I knew it was going to be great. You are great. The audience, we beat our goal twice, 3 times. Thank you, everybody. Take
Thank
care.
you. So
All right,
nice to
thank
see
you.
all here.
Thank
Yeah.
you.
Bye
So-
bye.